Function and natural logarithms. This is our class for today. This class is for college calculus. It's easy class. It's not difficult. It's not hard. Just be focused on some ideas. We have. I'm going to solve. I will solve three problems. This is the first one. First problem, we have to evaluate it. Log 2 8 minus log 2 5. Okay. First of all, an inverse function, which is called the logarithmic function, with base b, and denoted this write by this way, log b. Okay, so we are going to have some ideas to review. We're going to have, for instance, here if this is inverse. This means inverse of x equals y. So this means f y equals x. Okay, there's some concept before to solve this problem, to see the background, where is coming the ideas for get the answer of this problem. Then, for example, you have this. Then we are going to have log b x equals y, right? Or therefore b is going to be to the y power is equals x. Okay. Another thing that important to review or remember here is the rules or the laws or the logarithms. The logarithms laws. If x and y are positive numbers, then we are going to have number one, the law or the rule number one. So we are going to have here. Let me use the right color here. Log. So let's look at this. X times y, okay, equals log b. Here is going to be x plus log bx plus log by. Okay, this is the number one. The second one you have, or we have log b of x over y, or x divided by y. This is going to be log b x minus log b y. Right? So pay attention in that. So this is the rules that you must to remember before to solve these problems. Logarithmic function and natural logarithms. So this is useful for that. So the rule number 3, or the law number 3, so log b, when you have a number x to the r power, this is equals r log bx. Yeah, like that. So what I mean r, so r is any real numbers. Any real numbers means r. Okay, so now keeping in mind these rules, remember you need to memorize these rules for this class. Okay, actually we explained it before. I teach this rule before, so that's why I teach this concept before, because in the future, almost in several classes, we have to use it. So that's why we have to remember this kind of rules. Okay, I'm going to erase and then solve the problem. It's very simple. So look at this. Very simple, very easy to solve the problems. I want to erase it. So just remember the rules. So the solution to this problem. So solution. Let's write solution here. Solution. So this problem, very easy. So here we are gonna have log 280, right? Of course, minus log 2 5. This is going to be equals So remember the rules. When you have this, it's going to be 80s here. I mean, log 2 of 80 divided by 5. Okay? So you simplify this, we're going to have log 2. This is equals, you divide it, how much is this? It's going to be 2 to the 4 power. 2 to the 4 power. So this is 60. Yeah? It's equals 60. Yeah, that's it. This is the answer. Very simple, no? Very easy problem. So this is the number 1. Let's go now to another to explain. Let me explain the this is logarithmic function. Now the natural logarithms. Now the natural logarithms. Natural logarithms. So this is with the base e. This has the base e. Okay, so it's called natural logarithms. So when you have some problem with the base e, this we call natural logarithms. For instance, I want to write some laws here, some rules too. So for instance, log e like this, x is equals in x, right? So this means here in x equals what? Remember, e to the y power equals x. Some rules should be, this should be number 1, and the second one should be in here of e to the x power is equals x. So when x belongs to the real numbers. So number 3, see, this is e to the in x, so power equals is going to be x when x is greater than 0. All right. For instance, here, in particular, if we set x equals 1, for instance, we got it how much? So we got it in e equals 1. All right. In this case, so it's just to explain it a little bit what I mean. Natural logarithm. Let's see. This is let's solve one problem. I mean, so we did one. Remember the first one. This is going to be the second problem. Okay, fine. When we solved one problem to show you what I mean logarithmic function. The first one. This one I'm going to solve this problem. Find x if x is equals 5. When this information, okay? Look at this. We have to apply some of these. So some rules. We have this problem. We have to find x if x is equals 5. We're gonna take the number b, the b rules. So from let's see, from b, this one, this problem here, we said that ink. So here, this one, we are talking about this looking in this rule. In x is equals 5, right? Is equals 5. So this means But I mean this. That means this e to the 5 power is equals x. All right. Therefore, how much is x? So x is equals e to the x power. That's it. That is very simple. This is, I mean, that should be one solution. This is one solution we can find. This is solution 1 and number 1 here. Let's do solution number 2. Yeah, because we it's possible to find another solution. So here, write in solution number 2, just write it in here. In x equals 5. This is a second solution. So therefore, e to the x, yeah, x is equals e to the 5th power. Okay, 5th power. So therefore, so this is another solution. It's the same thing. X here equals e to the 5th power. Right? This is the solution number 2. Just using these rules, you can play. Just play with maths. Okay, using this rule. I told you you need to memorize some solution. Okay, this is problem number 2. Let me erase everything and let's try to solve another problem. Just applying we talking about natural logarithms with base e. Okay, problem number 3. Solve equation. Okay, solve the equation. Let's see. The equation is a little complex. E in x. Now let's write numbers. It's a little bit complex, this one. Let me write numbers here. Let's write here 5. Let's minus 3x. It's a power equals 10. Okay, let's see. All right, so next step, this is the problem. So the first step, here we are going to have in of what? Of this number inside e to the 5th power minus 3x, all right, equals in 10. All right. So now here you are going to have from this data 5 here, 5 minus 3x right here equals in 10. All right. So it's easy. So now here is 3x equals here it's going to be 5 times in 10. No, minus negative minus in 10. Yeah. The solution, then our conclusion. The conclusion should be therefore we are going to have x equals 1/3 times 5 minus in 10. We have to use the computer calculator to find the right answer because this is allowed to use this a scientific calculator. Okay, scientific. If you use a scientific calculator, see this. Let me see. Which is it's going to be the answer. So it's not exactly right. Not exactly. But it's 0.8 991. Okay, This is the solution. Actually, this is the solution, but we have to find exactly, or not exactly, approximately, using the calculator or in your computer or your cell phone, use the calculator and then find, you have this scientific functions, you got it, this answer, okay? So this is working with the natural logarithms. This is the answer for our problem. Solve the equation, this equation equals, so x, how much is x? Because we need to know how much is x is equals like approximately this 0.8991. Okay, exactly the number. All right, that's it.